Last time we had started 3.5, talking about mental math and estimation. We haven't gotten to the estimation part yet, but we've done mental math for addition and subtraction. And we are going to pick up where we left off and talk about some mental math for multiplication next. You guys ready?
Yeah.
Yeah, of course you are. All right, so we're going to take a look at 46 times 5. Probably not something you're going to do in your head on a regular basis, but we're going to break it apart kind of like we did with the addition one actually at the very beginning last time. So what we're going to do is we're going to multiply the 40 times the 5. Which gives me what? 200. And then we're going to add to that multiplying the 6 times the 5, which is going to be 30. So we get 230. This is called front-end multiplying because you're multiplying the front of it first and then the second value of it. Works pretty nicely when you're multiplying by a one-digit number because then you end up breaking it apart into just one-digit multiplication. And that's why that was so friendly, is because it's just one-digit multiplication. Now, we had a method last time called compatible numbers for addition. And remember when we were looking for compatible numbers for addition, we were looking for quantities that pretty much added up to like tens or hundreds or something like that. Well, we're going to do the same thing here, except that we're going to be looking for numbers that multiply to, well, they are going to be whole numbers. We're still working in whole numbers, but yeah, things that end in zeros are awfully friendly. In particular, if you find any things that end in tens, that's, I mean, not end in 10, but have, like the number 10 or 100, that's great. But yeah, if we can find something that ends up having only one of the digits that's not 0, that's really helpful. So do you see, there's a couple options here on doing this. Do you see a couple of them I could do? 4 times 5. 8 times 5 would have worked, and it will work again. We've got another 5 here. Good. So that's 40. And then I've still got another 2 at the end. Here, I'll just write a 2 like this. So I end up still having one-digit multiplication to do, but I only have 3 of them now instead of 5 of them. That's helpful. Lots of 2s and 4s as well. So you could do this in any order you'd like. I think that probably we can do all of these in our head because it's just 2s, really. So 20 times 40 is what? 800 times 2 would be 1,600. So what you're really doing is you're reorganizing it, right? You're moving numbers around. That's the commutativity property, right? Commutativity allows you to do things in different, I didn't say it right. Commutativity allows you to switch the numbers. Associativity allows you to do things in a specific order. And so we're switching the numbers around, and then we can do them in whatever order we want. So the commutativity and associativity are both using this here.
When we're doing our homework, do you want us to write out all of the mental math we're doing?
Basically what you're seeing me write out is kind of what I'm expecting to see. You're going to have a few steps in there that's going to explain to me what you're thinking as you're doing it.
Okay.
But there are things that as you're thinking, you should be able to think them through in your head without writing them out if that's what you're, because that's actually really the point,
yeah.
right? Yeah.
Okay.
So that's what you're looking at. It's a good question. The next one's probably something that you haven't thought about doing before. It's called thinking money. All right, so thinking money, why would that be helpful? Well, because you use money and you're very familiar and comfortable with using money quite a bit. So in particular, when you're multiplying by 5, if I'm telling you to think money, what would that 5 represent? A nickel. This is 5 nickels. 5 is representing a nickel. Let me just write it that way. So this is kind of like saying I have 46 nickels. Can you guys imagine that? And you're wanting to know how much money you have. Did I put the L and the E in the wrong place? Is it L-E? E-L? Okay. Good. Evidently I don't know how to spell nickel. I wonder if I have it written down. Oh, I've got it written on my paper, right? So at one point I knew. All right, so this is like saying I have 46 nickels. I almost wrote it wrong again, just so you know. But 46 nickels would be the same as something else. What else could you do that would be easier multiplication? Dimes would be much friendlier. Why would dimes be so much friendlier? Because it's a number 10, right, in terms of value. How many dimes are the same as 46 nickels? Yeah, so 23, right? 23 dimes. So if I have 23 dimes, how much is this? 230.
You're not writing it as money, right?
No, you're just thinking about it like you would money.
Just
46 nickels, 23 dimes. So what about the next one? We're still thinking money. That's quarters. Right, this is quarters. Yes, you all did get excited. All right, so if you have 44 quarters, what would be nicer to work with than quarters? Dollars would be so much nicer. How many dollars would this be? 11. Why? You just divide it by 4, right? So this is $11, but I was thinking of it in terms of money, so this would be 1,100 because I was doing it in cents. That's what we were doing before. 1,100. You don't have to like it, but some of your kids might. You might have to teach it. That's right. Think about it in terms of money.
Works with like 1, 5, 10.
You know, the reality, Allie, is that most of the methods only work in certain situations. Like if you think back over here to the compatible numbers, if my numbers had not been given to me with 5s, this would not be very helpful, right? If I had 2s and 3s and 6s and 7s and 11s, compatible numbers doesn't make any sense. So most of these methods have the feature that they only work in certain situations. But if you think about it, if you were given in real life situations certain numbers and you had sort of these patterns of how you could think about things before, you'd probably be able to look at it and think, oh, I could think of it like this, and that's kind of the idea. Yeah, they do not work independently for every single example, for sure. All right, we're in a division. Just like that, we're at division. The first one is called breaking up the dividend. So what we're going to do is we're going to take the 6318 and we're going to break it into 2 pieces. Any idea why that might be nice? Yeah, they're both divisible by 9. So I'm going to divide them both individually by 9. So if I take 63 and I divide by 9, what do I get? What? 7. Okay, I'm sure I heard somebody say the wrong number. Whew, I was a little bit worried. So this is 7. And then, of course, let me write it out a little bit differently than that. I'm going to write something different in a minute. The 63 is 6,300. So when we divide by 9, we're getting 700 out of it. Okay? And then over here, I've got the 18 divided by 9. So 18 divided by 9 would be 2. So I end up with 702. I don't want you to think the answer was 72. That's why I wanted to show it a little bit differently.
Can you still do it where you would put like the 7 on top and then like the 2 in the right place
Yeah.
and then the 0?
Yeah, you'd have to be really careful when you're working with it that you remember that there is a place value here that you're sort of skipping over for the 0. But yes, you can do it there. I'm going to do it a little bit differently again down here. This is actually using compatible numbers. I can't break apart 400 or 425. That's very friendly, but I can break it apart if I think about what the number actually is. So the number 425 is really 400 plus 25, right? And 400 is divisible by 8 really cleanly. Not 4, but 400 works great. So how many times will 5 go into 400? 80. And we're looking at the number 40 when we think about that, right? So 5 goes into 48 times. So this will be 80. And then 5 goes into 25 5 times. So this gives me 85. And this is actually a method that I use quite a bit, where I break it apart into something it is actually broken apart. And the first one we broke it apart as well. It's just that it broke apart without ever, you saw the 63, right? It was there. 63 is divisible by 9. 4, not divisible by 5. So you have to think about it slightly differently. Breaking apart and then using compatible numbers. All right. The other topic of this section was estimation. Please be careful when you're doing your homework and when you're doing your test that you're being observant of whether or not you're supposed to be estimating or whether or not you're supposed to be actually finding the answer exactly, okay? Because some of the methods have similar names and you need to ask yourself what you're doing and where. Okay, so for instance, you've seen this now 3 times. You saw it on your last test, didn't you? Front-end estimation. I think it was your test. Maybe it was my Math 2 test. What's the other one? Okay, they saw it recently. You saw it just a moment ago right here. front-end multiplying, right? And we're going to do something here now called front-end with adjustment. So what does front-end do? Well, front-end actually first takes all the first numbers and just adds them together. Okay? So what we're going to do is we're going to take all of these numbers and we're going to add them as though we had 300, 400, and 200. Okay? So if I add 300, 400, 200, I get fantastic 900. Adjustment means looking at what you have left and deciding if things are approximately equal to something else. For example, if you take a look at this one, the first one and the second one, if you combine them, what are they about? No, 32, 62. About 100. Somebody got it. There we go. All right. The 32 and the 62, the remaining part left over that I'm looking at. The 32, the 62, it's about 100, isn't it? It's not exactly 100, but it's close. It's close enough. If we're asking ourselves an estimation for a value, it's fairly close. So that value right there is about 100.
Did you say 90 and
Yep, you could. You could say it's about 90. It's nicer when things are values of 100.
Right.
Just because they add simpler, you got fewer zeros and things like, or fewer numbers that are not 1 and 0, really. And then the number 25 at the end, we've got about 25. We've got that 25 left over. Okay, again, it's an estimate. So this is approximately then what? 1,025. Exact? No, it's not exactly. It's a little bit high actually because that, like you said, the 32 and the 62 could be run down to 90. But it's close.
So we don't want to subtract the 6 that we added?
We're not asking to find an exact value. We are estimating. So our goal is to just keep things in an estimate kind of picture. All right, these, again, are like doing compatible numbers. So we're going to group them in such a way that they're like nearly compatible. They almost add up to what we want. So what do you see here? A couple of numbers that sort of almost add up to something nice. Okay, we got to take the whole number as a whole. 4255, okay. So those add up to about what? About 100, all right. 7135, add up to about 100. And then I've got this number that's 64 at the end, which there's really no reason to change it at this point, that one, right? Because, so this would add up to what? 264. Now, when I did mine, I just want you to see another option so you can see that your answers might not match. When I did mine on my paper, I didn't group those numbers together that you guys picked. What did you, well, let's go with what you did. What did you do, Skylar?
Well, first I did it the 42 and 64.
Yeah, that's the one that I have down. So what did you get for that one? About 100. And then what else did you do?
The 7.
These two? And that's also about 100, right? And then you have the 55 here. So your value would have been something like 255, right? Is it close to the other one? Yes. Yeah, 255, 264. They're close. They're close. They're still close together. Yeah. Actually, I don't even think that's the ones that I did.
I did the 35 and 55 together because it makes 90.
Here's the ones that I did. Let me write down the ones I did. My point in showing you this is that there's not a right or wrong way to group them. I mean, there are some approaches that are a little more natural than other ones, which is why we tend to still say, and I grouped these like you did. When I have mine group, I grouped the 35 and the 64. Is that one when you said, Andrew?
Oh, I said 35 and 55.
You said 35 and 55. Okay, we'll go with what you have. 35 and 55, and you said 90.
Yeah.
Ooh, I don't like 90 very much.
Well, that's a question. I mean, that's my question to you. I mean, if you're estimating, you can add these together quick where it's zeros and ones, whatever, and you estimate its exact number. Because once it gets down easy, it's easy in that to count as onesie, twosies, ends at the bottom.
That's true. That's true. It is. What I had done is I had done, it looks like those two and these two. No, these two. Those are the two that I had grouped. And again, they're about 100 each. And the one that I had left out was the number 71. So my total is actually 271 when I had done it on my paper.
It's supposed to take you forever to grade.
They're all very similar answers, right? Yeah, sometimes they do take forever to grade. The joys, the joys. All right, clustering. Clustering is a very interesting idea. If you take a look at all of these numbers, what do you notice about them? They're all 400s and 500s. Anything else?
They're all about 500.
They're all about 500. They're sort of clustering in they're all sort of grouped around the same number, and the number is about 500. So these are all approximately 500. So what's an easier way of doing something that's the same number 5 times? Yeah. So we can take 5 times 500 as these are approximations we recognize. And I would end up with roughly 2,500 for the value here. And again, does this work for everything? Well, no, of course not. But imagine that you went somewhere and you got a whole bunch of items and everything in your cart was about $1. Some things were 50 cents, some things were $1.50, and you're just sort of asking yourself about how much am I going to spend? Well, if you just counted the number of items, then you'd know a rough estimate of what you would be spending, right? This is all about $1. Rounding. Now, this does not tell you how to round, right? So if you are rounding, you have to know what place you're going to round to. If they don't give you a place value, you get to pick. If they do give you a place value, then you have to use what they use. So let's try a couple of them. Let's say you're rounding to the thousands place. So the thousands would be the first digit here, right? The 4, the 3. So what would 4,789 be rounded to the thousands place? 5,000. And what would 3,148 be? 3,000. And so this adds up to 8,000. So if we're rounding to the thousands place, that's what we get. Let's try hundreds place just so that we can show that that's not the only option. What if you rounded 4,789 to the hundreds place? 4,800 or 4,800. How about 3,148? 3,100. And if you add them up, what do you get? 7,900. Are those fairly close estimates to one another at least? Yeah, you're pretty close. Using the range. Range is an interesting idea. Now, you have heard range in a variety of contexts, probably in math. Can somebody give me an example of where you've heard the word range applied? Mean, median, and mode. So that in like a statistics sense is what you're doing. That's the closest one that we're going to use on this one to our description. Where else have you heard range? You remember? Remember domain and range from algebra? Domain is your x values, range is your y values. That's another place you've heard range before. Range here looks more related to the idea from statistics. So range in the idea of statistics is sort of giving yourself this idea of how much things are spread apart. That's what you're looking at when you do it from statistics. So what we're going to do here is we're going to kind of give ourselves an idea of what happens when we round down and when we round up. Now over here, this rounding is just rounding. Okay, so you're rounding with regular rounding rules. 5 and up, you round up. 4 and down, you round down. So what we're going to do is we're going to ignore the rounding rules, and we're going to round everything down. We're going to round everything up. So if you're looking at, and we'll do the hundreds place because we weren't indicated what to do differently. So let's do hundreds. So if you're looking at the 370, you would round down to 300 if you're rounding down. 647, you would round down to 600 if you're rounding down, for a total of 900. Recognizing, of course, that that's on the low end. That's smaller than the actual value. And then rounding up means rounding both of them up. So 370 would become 400, and 647 would become 700. And if you add those together, you get 1,100. There we go. So you're sort of giving yourself a lower and an upper bound. So the range is, whoops, 900 to 1,000. So the answer, if you will, is somewhere, but not 1,000, 1,100. Can I remember right? The answer of the real value is somewhere in between 900 and 1,100. And sometimes knowing the range, the lower end and the upper end of something is really sufficient enough to make sure, for instance, that you brought enough money that you're not going to leave the Thunder Stadium with no food or something like that, right? You got to make sure you have enough money there or something like this. All right, multiplication division, same idea. Front end estimation. So front end estimation means taking the first value and multiplying it by 4. Okay, this is the third time you've heard front end today, now for sure. Third method. So you're going to take the first number and multiply by 4 to give you 1,200, good. And you're going to take the second digit, which would be 80, and multiply by 4 to give you 320. Now, if you were actually finding the real value, what would you do next? You do the last digit by 4 as well, okay? With estimation, the idea is that if you multiply the first 2 digits, even if it had been like a 4-digit or 5-digit number, you're getting awfully close. So you're only going to do the first 2 digits. So in this case, I'm doing the 3 and the 8 that we're multiplying. All right, so 1,200 and 320 would give me what? 1,520 is my approximation for this value. Again, if I went one more step, it would be exact. Hence, it wouldn't be an estimation. Okay, it'd be great. You can do it. That's fine, but not if it says estimate. If it says estimate, we each use the first 2 digits. Compatible numbers. Now, 4132 does not break apart very nicely like the other ones did. Like, I could do the 4. That's great. But the 132, that doesn't work. That's not a nicely divisible by 4 kind of thing. But if you take a look at 4,132, what number close to it is nicely divisible by 4,000? Yeah. So you're just taking this and you're changing to a number that very nicely does, in fact, divide by the value you care about. And you're saying that this is approximately 1,000 then. Exact? No, not exact, but it's approximately. It's an estimate of what we were looking for. So you turned 4132 into a number that is compatible with 4. Now, is it the only number? No, but is it the simplest number? Yeah. So if you chose something different that was maybe you chose 4112 or 4,120, that wouldn't be bad, right? Because the 4 is divisible by 4, the 12 is divisible by 4. So that wouldn't be the worst thing in the world. And if you did, you'd end up with 103. And then the 0 at the end. So that's not a terrible value either, but it's not quite as simple as the first one. So is there room for you to choose something slightly different? Yeah, there is. There's nothing wrong with it. But the goal is to do something that you can do quickly, estimate in your head. I mean, that's the idea. Any questions on that one? All right.